The first humans to land on Mars will not be celebrated. Not immediately. They will land, and the world will watch, and there will be cheering and tears and historic broadcasts in every language on Earth. And then the cameras will cut away. The headlines will move on. And those humans, those specific people who volunteered to stand on red dirt 140 million miles from home, will be completely, utterly, terrifyingly alone. And the survival will begin. Not the mission, not the science, the survival. Because everything about Mars is designed by physics and chemistry and distance to kill the people who go there. And the most disturbing thing about the first human Mars mission is not whether they can get there. It's whether they can stay alive once they do. Start with the atmosphere. Mars has one. That's the first thing people get wrong. They imagine stepping out onto Mars into pure vacuum, like the moon. Mars has an atmosphere, it just doesn't have one you can breathe. The Martian atmosphere is 95% carbon dioxide. The air pressure on the surface is less than 1% of Earth's sea level pressure. Stepping outside without a suit on Mars would not feel like breathing bad air. It would feel like nothing, because your lungs would have nothing to push against. The gases in your body would begin to expand. You would lose consciousness in seconds and be dead within 2 minutes. The atmosphere that does exist offers almost no protection from radiation. Earth's magnetic field deflects solar wind and cosmic rays. Mars lost its global magnetic field billions of years ago. What reaches the Martian surface on a daily basis would give an unprotected person a lethal radiation dose within months, not years, months. The first humans on Mars will be living inside structures specifically engineered to keep a hostile planet from dissolving them at the cellular level. And those structures have to work perfectly, every day, without exception. Now, consider the distance. This is the part that doesn't get talked about enough. When Apollo 13 had its oxygen tank rupture on the way to the moon, the crew was 4 days from Earth. They looped around the moon and came home. They survived because home was close enough to reach in a damaged spacecraft running on emergency power. Mars is not 4 days away. Depending on where the two planets are in their orbits, Mars is between 3 and 8 months away by spacecraft. And the orbital mechanics of getting there and coming back mean that departure windows, the specific periods where the journey is even possible, only open every 26 months. If something goes wrong on Mars, there is no rescue mission. There is no emergency return. There is no cavalry. Houston can hear you, but Houston cannot reach you. And even the communication between Houston and Mars is not a phone call. The signal delay between Earth and Mars ranges from 3 minutes to 24 minutes each way. When the first humans on Mars face a crisis, and they will face a crisis because space does not run missions without crises, they will have to solve it themselves, in real time, with whatever they brought with them, while waiting up to 48 minutes for a round-trip conversation with Earth. They will be more isolated than any human beings in the history of our species. The food situation is where it gets existentially strange. Every calorie consumed on Mars either came from Earth or was grown on Mars. There is no third option. Bringing enough food from Earth for a multi-year mission requires extraordinary mass, and mass is the enemy of space travel. Every kilogram launched from Earth costs enormous resources. So the plan, the serious plan, the one engineers are actually working on, involves growing food on Mars, in soil that is not soil. Martian regolith, the loose surface material that covers the planet, is toxic. It contains perchlorates, chemical compounds that disrupt human thyroid function and are poisonous if consumed. The surface of Mars is not a place where you plant seeds and wait for harvest. It is a place where you must first chemically process the ground before anything edible can grow in it. The greenhouses must be pressurized and sealed. The growing systems must be closed-loop, recycling water and atmosphere. A single breach, a single equipment failure, a single fungal contamination of a crop could cascade into a food crisis with no resupply arriving for over 2 years. The first humans on Mars will eat every meal knowing exactly how many meals are left if the systems fail. But here is the part that separates this from every other survival story ever told. They will survive, not despite these conditions, because of who they will be, what they will have prepared, and what human beings have already proven they can endure. Mars missions have been simulated on Earth. In Hawaii, on the slopes of a volcano, crews have lived in isolated domes for up to a year, following Mars communication protocols, growing food, managing conflict, solving problems with the resources available inside the habitat. Every one of those simulations has produced data showing that human beings can function, cooperate, and maintain psychological stability under conditions that approximate what Mars will demand. The people selected for the first Mars mission will not be chosen only for technical skill. They will be chosen for psychological resilience, conflict resolution ability, adaptability under pressure, and the rare capacity to remain rational when the stakes are absolute. The radiation problem has solutions in progress. Underground habitats cut radiation exposure dramatically. Mars has lava tubes, natural tunnels carved by ancient volcanic activity, large enough to contain entire cities, already shielded by meters of rock overhead. The first crews may not live on the surface at all. They may live below it, emerging in suits for surface work and returning to shielded environments below ground. Pharmaceutical countermeasures for radiation exposure are advancing. Materials science is producing lighter, more effective radiation shielding. The problem is real and serious, and it is being solved with the same systematic engineering that solved re-entry heat, rocket propulsion, and life support on every mission before this one. The atmosphere problem is also partially solved by the atmosphere itself. NASA's MOXIE experiment, which flew on the Perseverance rover, already demonstrated the ability to produce oxygen from Martian carbon dioxide on the surface of Mars. A scaled-up version of that technology means the first humans on Mars can breathe air made from the planet's own atmosphere. They bring the technology. Mars provides the raw material. The planet that wants to kill them will also help keep them alive. There is a moment that will happen on that mission that no simulation can prepare anyone for. One of those astronauts will walk to the edge of their habitat's viewing area or stand on the surface in a suit and look up. And Earth will be visible. A pale blue point of light in a dark sky. Smaller than a star appears from here. Tinier than anything that contains everything they have ever loved. Every human being who has ever lived. Every ocean, every city, every forest, every face they know. Compressed into a point of light so small you could cover it with a fingernail. That moment will be the most alone any human being has ever felt while still being alive. And they will turn back toward the habitat. Check the seals. Review the systems. Eat whatever the day's ration is. Sleep in the low gravity that pulls at their bones slightly differently than home. And wake up the next morning and do it again. Because that is what the first humans on Mars will actually do. They will survive by deciding to, every single day. In the most hostile environment our species has ever attempted to inhabit, with the skills and technology and sheer human stubbornness that got us to the moon, that kept people alive on a broken spacecraft in 1970, that has pushed every boundary this species has ever encountered. Mars will try to kill them. They will not let it.